Okay, so let me recap, just because I accidentally stopped the video and, anyway. So, our conditions on the one sample test, random, nearly normal, proceeding with a one sample t-test, the null hypothesis, we have a mean of 30, and the alternative hypothesis is a mean of greater than 30. Otherwise, you could write the mean of 60%, and the alternative being the mean is greater than 60%. Make very, very certain that you're using mu for that hypothesis. So in the calculator, there's two different ways to do this. You can run that's on the wrong one. You can run the one-bar stats and show all your work. So calculate the one-bar stats for list 2. That's where my after list is. And we have a mean of 33.15. And a standard deviation of 2.323. And an N of 20, which means our degrees of freedom is going to be 19. So I'm going to show you the work that I expect you to show on here, and then I'm also going to do this, run it through the test part of the calculator. So our T-statistic for 19 degrees of freedom is found by taking the observed mean, 33.15, minus the hypothesized mean of 30, divided by our standard error. That standard error is calculated by our standard deviation, 2.323, divided by the square root of n, so the square root of 20. So that's our entire t calculation. I can put that into the calculator in one shot. Just be careful with your parentheses. So 33, I'm going to clear that whole thing. 33.15 minus 30 divided by, and I don't know if you need parentheses for the second part, but I'm going to do it just in case, 2.323 divided by the square root of 20, close and close, which gives me 6.064. So let me be really clear about this for your upcoming tests. On the single sample t-test and the matched pairs test, I do expect you to show your mechanics and correct notation. So from the T-statistic, our probability that T would be greater than 6.064, and we're going with greater than because that's what our null hypothesis, our alternative hypothesis says. So whatever this symbol is, that is as well. So the probability that T would be greater than that, we go to T-CDF. Not that one, sorry, wrong one. So second bars, T-CDF, 6.064, comma 99, and then your degrees of freedom of 19. That's one fewer than your sample size. So we get, don't forget to look all the way to the end of that line. You're never going to have a p-value greater than 1, so if something comes up like that, make sure you look to the end of the line. We have a teeny tiny p-value, so 3.92 times 10 to the negative 6. Or nearly 0. So that's our mechanics section. Our conclusion, based on the very low p-value, and you can just say low, are we going to reject or fail to reject? Reject. I reject the null hypothesis. Which means there is evidence of my alternative. So there is evidence that after training, players will be able to throw strikes at least 60% of the time. So make sure you are answering the question that was asked of you. Make sure that if you have data, you are sketching that histogram. Obviously, you can't do that if you don't have data. Make sure you are listing what tests you're doing. Make sure your hypotheses are clear. Show your T-Statistic calculation and your p-value. Make sure you get the notation on your p-value. Link your p-value to your conclusion, whether or not you reject or fail to reject, and then make sure that your conclusion is in context. Any questions on any of that? On the second part, is there evidence that training is effective in improving a player's ability to throw strikes? We have to check the conditions again. We can, the randomization isn't going to change. So I'm just going to say see above because it's the same thing we just did. Not random, but also not a concern about bias. The nearly normal condition, we need to check that differently because the histogram that we're looking at is now, well, let me show you first the list. So this third list here is where I did list 2 minus list 1. You can't see that very well, sorry about the lighting. So I'm going to do the histogram of that list 3 of all my differences. So when I plot that, I'm going to do list 3. Nope, that's not what I meant to do. List 3. Frequency is just not Y. Goodness. 1. And then I'm going to graph and zoom 9. So I have a little bit of an outlier there, but there are 2 of them. There's not that big of a gap. So I would call this roughly unimodal and symmetric as well. In addition, the sample size is greater than 15, so we don't need to be too concerned about the shape of that. So draw that or just sketch it. That one's a little lower. So roughly unimodal and symmetric. And n is greater than 15. In addition, the paired data, each player is paired with their before and after. And I'm actually going to specify after minus before because that's how I put my numbers in. So I'm going to proceed, conditions met, I'll proceed with a paired t-test. Okay, so in all the stuff in your book, it has the hypotheses first and then the conditions. I tend to do the conditions first just because sometimes that will help you catch if you're doing the right test or not, and you'll write your hypotheses differently based on that. Either way is fine as long as both parts are there. So don't forget, even as you write your conclusion, if you say you reject the null hypothesis, make sure that you have written your hypothesis somewhere there, because that is a part that people have a tendency to forget. Another thing people tend to have problems with the pair t-test is they don't write the parameters correctly. So the null hypothesis is that our mean difference, so mu sub d equals 0, meaning there is no difference in the before-after, no significant difference. And the alternative is that the mean difference is greater than 0. If you did your numbers as before minus after, you would be less than 0. I did mine after minus before, assuming that, since what we're looking for is an improvement, we're assuming that the number of strikes they would have thrown after would be greater than the number of strikes they threw before. If you did it the other way, your sign would be switched around. And everything would be the same except for your T-statistic would be the opposite sign of what I get, and that's perfectly fine. It is a good idea to put somewhere which direction you're going, though. So, I'm going to run my statistics on L3. So I have an observed mean difference of 0.1, standard deviation, and I keep putting that sub D, that's important with the matched test, of 3.323. Did I put in the L3? Yeah, I did. And then my N is 20 pairs. Degrees of freedom is 1 less than the number of pairs. So I'm going to calculate it almost exactly like I did, or pretty much exactly like I did with the one sample t-test. Once you get your L3, once you get your list of differences, everything's pretty much the same as a one sample t-test, except in how you interpret your conclusion. So T equals our observed difference, 0.1, minus our hypothesized difference of 0, divided by the standard deviation, divided by the square root of 20. So that's our standard error right there. And then put that in the calculator. I'm getting 0.1346. And then my probability, or my p-value, probability that t would be greater than 0.1346. Is that TCDF? Keep going one too far. Comma 99, comma 19. So 0.4472. So, and one of the things you might note, I think, if you find the mean for the before, I think they're already greater than 60% beforehand. I feel like we calculated that last year. So the p-value on this, is that considered a high or low p-value? Pretty high p-value. So based on the high p-value, I failed to reject the null. There is not evidence that the training is effective. In improving a player's ability to throw strikes. So in technical terms, statistically, in that what we're actually saying here is that there is not enough evidence that the mean difference is greater than 0. So whenever you're talking about whenever you talk about your conclusion, you are either failing to reject or you're rejecting the null. In this case, we did not reject the null because we don't have enough evidence that this is true. And in fact, that p-value was so high, we could safely say we have no evidence that that's true. So it's your decision, the reject or fail to reject is about your null hypothesis. Your context part is you're saying you either do or do not have evidence of the alternative. And in this case, we don't have evidence that the mean difference is greater than 0 in the after minus before. So in answering their question, there is not evidence that the training is effective at improving a player's ability to throw strikes. So on both of those, I'll show you really quick. This is what you would do in a pinch, but I do want you to, like what I showed you on the mechanics is what I expect to see on the one sample t-test and the paired t-test in terms of showing your work. Now, if you're running out of time, then don't show all that because you want to make sure you get in what you need to get in to write a solid conclusion. So if you look at stat over to test, t-test, this is, I'm looking at, let's look at the first one. That was my list 2. I was suggesting that the mean difference is 30 for my null hypothesis, because that would be 60% strikes. I'm in list 2 for my afters. I was suggesting in my alternative that it was that the mean difference is greater than my hypothesized mean. Not my mean difference, I'm sorry, my mean strikes thrown was greater than the hypothesis. So I calculate and get pretty close to what I got there. Might be some differences in rounding, but and you can run this, like honestly, instead of doing the 1-bar stats, you could just as easily run this and get your mean and your standard deviation, but make sure you're still showing your work for the purposes of my test. What you do on the AP exam, I would say, depends on how sure you are that you're putting the numbers in correctly and if you have time to put all the numbers in. And I simply say that because, as I've said before, I'm still not certain how much they expect you to show. Sometimes it sounds like they want you to show all the calculations, and sometimes it seems like they don't care. On the second one, on the matched pairs test, I am doing a t-test again from the data. Now I'm saying my hypothesized mean difference is 0. I'm going with list 3 because that's where my differences were, and once again I'm hypothesizing, or for my alternative, that the true mean difference is greater than my hypothesized mean of 0. Calculate, and I see my t and p-value roughly the same as what I got there, so I would reach that same conclusion. So basically, what you don't see from the calculator that you do see with the work is your t calculation and your p notation. Yeah?
I did a